Hello, Pycon JP 21. Thanks for having me. I'm very excited to be part of this event. I'm Guido van Rossum, Distinguished Engineer in Microsoft's Developer Division. I'm a Dutch citizen, but have lived in the United States for the last 26 years. As you probably know, around 1990, still in the Netherlands, I started working on a new programming language, mostly as a hobby project. After about a year in 1991, I open sourced it, named it Python, and since then it has seen explosive growth, first for scripting, then for web applications, finally for machine learning, which surprised me the most because I don't know anything about that subject. For most of this time, I've acted as the lead developer, or BDFL, Benevolent Dictator for Life, for Python. In 2018, I retired from the BDFL position, but I'm still an active Python core developer, and I still know most of the things that are going on in the Python community. Well, okay, so I've worked for a string of startups and large tech companies, but my heart has always been with Python and open source in general. About 2 years ago, I decided to retire for good, not from BDFL post so much, but just from working. But the pandemic put an end to those plans, and my plans were mostly to go travel a lot and eat out a lot. But both those things were kind of blocked by the pandemic, and I felt a little bored, and I went looking for a job again. I knew that Microsoft had become very friendly to Python and open source, which it hasn't always been. And I actually happen to know some people at Microsoft's DevDiv, the developer division. So I decided to apply for a job there. And it turns out that Microsoft was basically very eager to hire me. So here I am. Well, let's see. Microsoft gave me a lot of freedom to choose a project once I had started. I looked into various things like Azure and machine learning, notebooks, but I found quickly that I wasn't really cut out to be a cloud engineer. And I also discovered that machine learning is actually a vast, I would say, humongous field, and it would take me many years to become useful in that field. On the other hand, working on CPython itself is something where I could start contributing almost immediately. And I sort of thought, well, CPython performance is an increasingly important subject. So I thought, okay, let's see what I can do for CPython performance. And I drew up a plan, mostly based actually on existing ideas that have been floating in the Python core dev community. And management was rather quickly convinced to give me some resources. Now, the main thing we're trying to improve in this project, at least as it's currently scoped, is the Python bytecode interpreter. We're streamlining parts of that interpreter, and we're trying to streamline parts of the data structures, such as the stack frames. We're also doing something called quickening, or what we also call a specializing adapting interpreter, which specializes certain bytecode instructions into faster ones using something we call inlining. Those faster bytecode instructions only work when the argument on the stack has the expected type. If that expected type is not there, we fall back on the original opcode. So that even though we specialize the bytecode, we still preserve the full backwards compatibility, which of course is very important. We're also looking at some other things. One key thing that we're trying to improve as well is startup time. And that's especially important for people who run a lot of small Pythons and scripts, or use Python to run utilities that they sort of string together in larger shell scripts. Now, one thing I want to mention is you may probably have heard that there have been many other attempts at creating faster Python interpreters, and none of those have been particularly successful. A few of those are still around, but they're like I would say 99% of all Python users are actually using CPython as it comes out of the box without any accelerators. An important part of the project, therefore, is that we're doing everything as open source, and we're merging all our work upstream in the main CPython branch on GitHub. We're being very careful with backwards compatibility, since the whole Python community is looking over our shoulders. And we want the next Python release that will have these improvements, or at least the first set of improvements, that will be Python 3.11. Of course, we want 3.11 to be very compatible with previous versions. We want it to be only faster, because if we also make other incompatible changes, chances are that people will say, don't touch Python 3.11, stick with Python 3.10. So we've had somewhat modest results so far. We're currently measuring around a 10% speed up compared to the latest official release, that is 3.10, which is actually coming out the first week of October. Next week from when we're recording this, although it's going to be last week from when you're hearing this. We expect to double the performance improvement by the time 3.11 is actually going to be released October next year. Even after that, we will continue to improve the performance in future releases. It may even be possible that at some point, not likely in 3.11, but 3.12 or beyond, we will be generating machine code in certain cases to give us additional speed up. Thank you for having me, Pycon JP 21. It's great to see all the excitement, and I hope that what I've just shared excites you about Python and its future. Once the pandemic situation is resolved, I'm looking forward to eating some great sushi with you all.